All right, we start with chapter 10. Correlation and regressions. There is a definition here for correlation, that a correlation exists between two variables when the value of one variable are somehow associated with value of the other variables, and then you have a linear correlations. I already placed a copy of this document online, so you could have it printed, and while you look at the video, it's a good idea to have that with you. All right. So what I have here is this. First I want to start a very simple example for you. Here, remember when you were taking an algebra class, when we asked you to graph a simple functions like that, if there is a function that is a first degree, means the power of x is 1, they call it linear equations. And linear equation, graph of linear equation is always a straight line. So graph of linear equation is straight line. And how do I graph a linear equations? First, you start with some numbers, like some arbitrary numbers. Let's say, and normally you need 2 or 3, but here I want to have more values for x's. So let's assume x is 0. So you plug that here, you find a y, x is 1, you put it back here, 1 plus 1, the y is 2, and so forth. When I plot all these points, you see that they all lie on a straight line, correct? So in that case, if I say, well, x equal to 4, and what is value of y, how do you find it? So what you do is you just find 4 wherever that number is, right? And you need to draw the straight line up. But since all the points almost lie on one straight line, if you connect these 2 points, and then you draw a straight line from 4, and then draw a horizontal line to the left, that gives you the value of y, which is, well, let's say it's roughly 5, okay? So the reason that you were able to find y value when x is 4 is because you have a very good correlations among x and y. X and y have very good correlations, and the value of y always depend on x value. You have to assign a number to x first in order to find the y value. So this is a very good example of correlation. So let's look at the definition again here. A correlation exists between two variables when the value of one variable are somehow associated with variable of the other variables. What is linear correlation? Exists between two variables when there is a correlation and plotted points appear that will result in a pattern that can be approximated by a straight line. Okay, so this is what you have here. Now, then let's look at this example. In this one, if I want to find x equals 7, then the same thing, you just go up. And so if I want to draw a line here, it should be a line almost, so that shows the point. They kind of lie on a straight line. They don't have to be exactly lie on this straight line. As long as they're clustered along this, you are able to draw a line. So in that case, if you really want to find the y value for x equals 7, when you draw a vertical line here, then you go to the left, and then you read your y value, whatever it is. This is in case you have a good correlations. Now let's look at this example here. equation is not given to you. See, like in the second example here, this example, equation was not given. All you had was just a graph, all right? When you have only the graph and you don't have the equations, for you to find a y value when x is 7, you gotta look to see if all the points kind of lie on the straight line or they are close to the straight line. And then you say, if that's the case, then right, then you just draw a straight line and or a line that actually have all the numbers very close to it. Then you are able to just move up from 7 and find your x value. This line, this is straight line, they call it regression line. And when you create an equation out of this, they call it regression equations. And we're going to discuss that on section 10.2. So what is regression line? Is just this straight line. Now, in this example here, the graph of some points are given. There are some points, x and y, okay? We don't know what they are. We plot them here. It's already plotted and given to us. Now, we have the graph. Now, they're telling us when x is 3, what's the value of y? How do I find the value of y? Because I see that points are not on, they don't lie on the straight line. So there is no way for me to draw a straight line since almost all these points are not located on the straight line. So in that case, you cannot find the y value, and then, or you just say, you know what, there is no correlation is very weak, so I can't do it. So you understand the difference between good correlation, strong correlation, and weak correlations. And when you have the graph, you should also remember that if the graph declining, if the straight line declining, remember in algebra, they had a negative slope. And when the graph is ascending or increasing, then we have a positive slope. And we need to understand that for the next one. Now look at these pictures here. Look, what they're asking us is this. There are 4 different graphs. This one, correlations, what's the maximum number for correlations? R is 100%. 100% or 1. Zero % is absolutely no correlations or 0. Okay? So you are between 0 and 1. So the middle is almost 0.50. All right. Now here, look at this one. R is given. It's positive 0.8, almost 0.9. So it is a good correlation. You see, most of these points, they are clustered around the straight line here. And remember, when you go in this direction, when increasing, it's a positive, and when the line is decreasing or declining, then R is negative. See, in both cases, you have a very good correlation. This is a negative correlation because it's going in this direction. This is a positive correlation since it's going that. Look, correlation is not good at all. Look at all the points scattered. There is no way for me to draw a straight line here. So correlation is 0.07, almost 0. We are talking about the linear correlation. Remember, linear, I said, is for a straight line. You don't have a straight line here. It's a curve. It's non-linear relationship. Okay? And then based on this, look. Linear correlation coefficient of R measure a strength of linear correlation between the pair quantity x value and y value. The linear correlation coefficient is computed by using formula 10 moment. Okay, so what's the measurement of good correlation versus a bad correlation? The value of R. Now, I will show you later on how to calculate that. How do we calculate this R in order to tell whether you have a strong correlation or very weak correlations? We are using two methods to find the R value. One is just if you want to do the hand calculation is all this, look. There are two formulas. We could either use formula 10.1 or formula 10.2. And what's the easiest way to do? Calculator. Finding R using technology, okay? So again, as far as hand calculation, there are two formulas that we are allowed to use. These two, and using the technology. So we start with this example here. Now, on this example, we want to calculate R using this table. It lists 5 of the pair data value from table. So there are 5 numbers here, or 5 pairs. Is the chocolate versus Nobel. So I think the easier way is to use the technology, but first we want to show you how to do the hand calculation. So if you want to do hand calculations, you realize in this formula, we need to find sum of x, we need to find sum of I, sum of xy, sum of x2, all this. So you create this table. These two columns are given. So you need to find x to the power of 2. That means take every number raised to the power of 2. Y2 means take every number here raised to the power of 2. XY means multiply all these. You put everything, and you have the R value of 0.795. So this is a method of using this formula. Here I show you the second method. The second method also you come up with the same value, but it's just a different method to use, okay? So in this one, again, you have these two columns, right? Then you need to calculate z of x and z of y, so you could put it in this formula, all right? This is formula for z of x, and then z of y also has their own formula. See here? You have z of x, z of y. When you find z of x, z of y, then you could find sum of zx, zy. Means, how do I find these numbers? Take these two, multiply, that would give you zx, zy. Multiply these two columns, give you zx, zy. And when you add all these numbers together, sum of zx, zy is the number that you need to use. At the end, in this formula, R is sum of zx, zy that you find from here over n minus 1. Since there are 5 pairs, n is 5, so 5 minus 1 is 4. Okay? And I show you here a couple of examples so you see how we came up with zx and zy. Like zx is this, right? We already understand how to calculate sample mean and the standard deviation of the sample for the first lines, or for all the x's, for all this. For all this, we find sample mean and the standard deviation of sample that give you zx, which is this number here. How do I calculate the zy? The same thing. You already have, for all the y value, you already calculate mean of y value, standard deviation of y value. You put it here, and y is 9, so I'll put 9 here. And so you do all these calculations, and then you find your z, okay? This is if you want to use hand calculation. But if you want to use the technology, then I had it here for you, okay? So first, obviously, you have to go to the stat edit and put L1 and L2, okay? So here, go to stat. Okay, stat edit. I already put L1 and L2 here. I already input those L1 and L2. Okay, so that's what you do. Input the data in L1 and L2. Then you need to go to stat and calculations, start calculation. Then since you are talking about two different groups, L1 and L2, go to the second one, two variance stat. See, remember the first one was when you were dealing with just like L1, just with one column. But if you're dealing with two columns for L1 and L2, then you get to pick that. Okay, so here you just want to make sure that all the numbers are in L1, L2. You don't have to do anything else here, calculate. So that gives you all the numbers you want, you know, sum of X, sum of X2. This is in case you need to take these numbers and plug into the formula. If you want to use the formula, if you want to use like this formula, you could take all these numbers from calculator if you want. Let's say there is a case that we ask you to show your solution and go through this, which probably is not the case in online class. But if we ask you to use the formula and do hand calculation, all these numbers, you could pick it from the calculator. Okay. All right. Now I want to go ahead and find the R value. Okay. So in order to do the R value, we also have that. And I guess I have it here too, but let me see if I have that on the next page here. So for that, they are saying that go ahead and go to test, stat, go to test, and they're saying go to linear regression t-test. You scroll down to find that one. I think it's F. See this one, F. Okay. Calculator already has L1 and L2, and you want to leave it not equal. Just leave it like that, not equal. So don't do anything here. Just make sure that it take all the numbers from L1 and L2. And then calculate. And scroll down. That's the R value. You see that R? R is 0.79. That's what you have. Okay. That's the number that you have here. So this is how to use your calculator, which is strongly recommended. And then here you should remember also that if the p-value from the calculator is less than alpha, then you support the claim. Means this, well, we used to say we accept H1, and if p-value is greater than alpha, you don't support H1, or we accept H0. All right. So what we did here, you know, for that example of the chocolate, sorry, let me just go through pages. You know, that example of chocolate and Nobel, we actually took just 5 numbers. But what if you take 23 numbers from the data? A lot of numbers from the data, 23. So we don't have the calculation here, but let's say we have taken, instead of 5 samples, we have taken 23 samples of chocolate and Nobels. And with that, we came up with R value of 0.80. Okay? See here. We know from the preceding example that value of linear correlation is 0.795 for the 5 pair of the sample. But if we use 23, if we use 23 samples, and then R is 0.801. Again, you don't see this calculation is already done somewhere. So now, how do I know this is a good correlation or not? To see if your correlation is good or not, then we have to use table A5, which I think I put a copy of that here for you, okay? And on that table A5, n is 23. We don't have 23, but 23 is somehow between 20 and 25. Alpha is given, is 5%. Alpha is 5%. So if alpha is 5%, you take an average of these two numbers. What does table A5 do? You know, anytime you have an R value and you want to prove that you have a strong correlations, your R value must always be greater than what they quoted in table A5. Table A5 is telling you that this is a minimum number that you're allowed to use for the R value. Or your R value must always be greater than the numbers that you see here, okay? So for 23 samples and alpha of 0.05, you should have a number between these two, between 0.44 and that, right? And let me see if I have that number here. And that number between these two, took an average is 0.42. So your number should be greater than 0.42 or less than -4. You know, you should not be between. If your calculation number fall between these two, then correlation was not good, it was very weak. Our R value for 23 samples was 0.8. 0.8 is greater than 0.43, see? So you fall into a correlations. So that proves that you do have a good correlations, okay? So again, table A5, what it does, it shows you whether you have a good correlation or not. You could also check that with a p-value. See? And here they kind of explain what I just told you, that if you fall between these two, there is no correlation. Now here in this example, they're saying that the claim is that there is a correlation. Means the difference is not equal to 0. That means correlation, the difference is not 0, it's always greater than 0. Null hypothesis is there is no correlations, so that would be R equal to 0. You know, instead of this R, they're using this one instead, okay? So basically here they are saying that R is not equal to 0. That means there is a correlation. We are saying no. What if R is 0? Is always, equal sign is always opposite of this, and also was a null hypothesis. Remember from the past? Okay. So now we have to prove that it is not. There is a formula. This is another method. Remember, another method to prove it, because table A6 would prove it that we have a correlation. But another method to prove that there is a correlation is you use this formula. You find the T of a statistic. You have all these numbers. You already calculate the R, and it was 0.801 for 23 samples here. N is 23, so that gives you the T value of 6.1. Remember, the T of calculation must always compare with T of the graph. How do I find these two numbers here for table A3? I think I have that one here too. Remember table A3 T distributions for 21 samples, an area of 2 tails 0.05. What is 2 tails? Because you have not equal here, right? Equal or not equal is always 2 tails. That gives you 2.08. So your number should not be greater than 2.8 or less than -2.8. These are the critical area, okay? And where does the 6.1 fall? It falls into the critical area. When you fall into critical area, remember you always reject HO. When you reject HO, means you have to accept H1, which shows that there is a correlation. So that supports that there is a correlation, okay? So this is another way to prove it. And also, if you use your calculator, shows 0 for p-value. If the p-value is less than significance level of 0.05, see if p-value is less than alpha, that also shows that we have to reject HO and accept the claim. See here? If p-value is less than alpha, support the claim. 0 is less than alpha means we have to support the claim. What was the claim? H1. It goes with this. All right. And here I kind of summarize the whole thing that I just told you. I show you that this is a p-value method that shows that you have to accept the claim, and this is formula. Okay, reject HO and accept HO. And this is how to use the calculator. This is a summarize of the formula. And then I put a couple of examples for you, and for you to, you could also graph all this. That's what they have it here. Here it shows, this is the instructions of how to graph scatter plot. Means when you have your L1 and L2, if we ask you to graph it, that's how to graph, okay? And then you could tell from the graph which one is the correct one. Now, this is the blank of, I'll just put a couple of examples for you. This one, and this is a solution, for you to just practice. And here I show you how to use the scatter plot to come up with a graph. How to use the table F5. This is another example I put for you here. It's very similar to that. And this is the solutions. This one, I want to just show you the hand calculations. And here I'm saying that RF calculation is greater than alpha, such and such, okay? So that would be sections 10.1.